So if we're going to graph f of x equals sine x, we know that this is a circular function, and we've also learned that this is a periodic function. So it's in the form f of x equals a sine bx. A and b are real numbers. Let's look first for the amplitude. The amplitude again is the height of the given graph. So we have the absolute value of a. Alright, so since it's in this form, a here is actually 1. We just don't write 1. So we have the amplitude equals 1. Okay, now we'll look for the period, or capital P equals the formula 2 pi over the absolute value of b. So b is the coefficient of x. Since we don't see any number, that means it's 1. So 1x, meaning we have 2 pi over the absolute value of 1, which is actually 1. Or simply, the period is equal to 2 pi. In degrees, this is also equal to 360 degrees. Okay, so to continue, we have here the Cartesian plane. So we'll emphasize the positive side, but again, the graph will extend on both left and right side. So we have to divide first the period, which is actually 2 pi, into 4 equal parts. So that gives us 2 pi. We'll start with pi over 2, or 90 degrees. Pi, this is actually 2 pi over 2, because this is 1/2 pi. This is 2 over 2 pi. We just simplified, so we have pi, because 2 divided by 2 is 1. So that is equal to 180 degrees. Next we have 1/2 pi, 2 over 2 pi, 3 over 2 pi. So in degrees, that's 270 degrees. And lastly, we have, this is actually 4 over 2 pi. So we just divide. 4 divided by 2 is 2. So 2 pi, which is also equal to 360 degrees. Since the given function is on this form, we have f of x equals a sine bx. We'll have the phase shift, which is 0, since c is equal to 0. We don't have c here. And then the midline, which is y equals d, is also 0, because again, we cannot see d here. So c and d are 0. So we'll emphasize on the first two parts. We have the amplitude and then the period. Okay, so remember these two values, the quantity, or the absolute value of a rather, is equal to 1. This is the amplitude or the height, and then p, the period, is equal to 2 pi. So since its sine function will pass through the origin. Alright, so we have to make a curve, which is like a wave. So this is the height, meaning that should be the highest point. Okay, so let's trace it, and let's make a curve, tracing from the origin going up since it's positive. Right, and then we'll go down. It must be equal to 1 as well. So we trace this. Sorry, it must be a smooth curve. And then going up again, let's put an arrowhead to indicate that it can extend indefinitely. Okay, so let me explain each of the points on the graph. Again, it must be a smooth curve. Sorry for the illustration or the graph. Alright, so we start with P of 0 degrees, meaning the point of intersection of 0 degree in a unit circle is 1, 0. And here we have 0 for x, and the value of y when the angle is 0 degree is 0. Therefore, we have the first point at 0, 0, the origin. Next, P of 90 degrees, or P of pi over 2. The coordinates are 0 and 1. So when when x, or the angle, is 90 degrees here, y is 1. So we have this point. We have pi over 2 and 1, or 90 degrees and 1. Next, we have P of 180 degrees, or P equals P of pi. P of pi. So the coordinates are -1 and 0. Since this is pi, or 180 degrees, and the value of y is 0, we have it at the x-axis. So this is 91 or pi over 2 and 1. This one is pi and 0 or 180 degrees and 0. Alright, let's have now 360 degrees. Or before that, let's have 270 degrees. Right? So if you notice, the point is at -1. So 270 degrees or 3 pi over 2, the coordinates are 0 and -1. Again, if sine of 270 degrees is the y coordinate, that is -1. So 270 degrees and 1 or 3 pi over 2 and 1. Lastly, if we have 360 degrees, that's the same as this one. Remember, the coordinates of 0 degree and 360 degrees are the same in the unit circle. 1 and 0. So we have here 360 degrees and the y coordinate is 0. So 2 pi and 0, 360 degrees and 0. Okay, this time let me show you the substitution part. So we are actually going to have first the table of values before we proceed with the graph, and this is how we arrive with the table of values. So we have first the values of x, the domain. X is 0. So if x is 0, f of 0 equals sine 0, and sine 0 is 0. Okay, I've shown you the coordinates a while ago. And then next, if f of x is 90, f of 90 degrees is equal to, so we'll have sine of 90 degrees, which is 1. Again, the coordinates from the unit circle. Of course, we have f of 180 degrees, if x is 180, equals sine of 180 degrees, which is 0. And then f of 270 degrees equals sine of 270 degrees equals -1. Alright, so for 360 degrees, you just do the same. F of 360 degrees equals sine of 360 degrees, which is 0. Notice that we've written here the coordinates 0, 0, pi over 2 and 1, or 90 degrees and 1, pi and 0 or 180 degrees and 0, 3 pi over 2 and -1 or 270 degrees and -1, and 2 pi and 0 or 360 degrees and 0. Finally, let me present the table of values. We have the values of x, the domain, 0, pi over 2, pi, 3 pi over 2, and 2 pi. This for actually the result when we divided the period 2 pi into 4 equal parts. And then for y, or the range, we have 0, 1, 0, -1, and 0. Y is the result when we substitute the input, or x, on the given function. So we have the graph here. It's a smooth curve, it's periodic, it's a graph of f of x equals sine.